So in this problem, we're given a state of stress. So we're given a state of stress that's defined in this stress element here. And we're asked to determine what is the new state of stress. So we're going from the old state of stress in the xy coordinate system to the new coordinate system, x prime, y prime. Okay, so we're given the angle that of rotation is 45 degrees, right, clockwise, right? So we were told that theta is equal to minus 45 degrees, right? That's the same thing as minus pi over 4, right? We also know that the sine of minus 45 degrees, or the sine of theta, would be equal to minus radical 2 over 2, while the cosine of theta would be equal to positive radical 2 over 2. Okay, so we know that our sigma prime matrix is equal to our transformation matrix, which is equal to cosine theta, sine theta, minus sine theta, and cosine theta, times our current state of stress, which for this case we have the x stress is equal to 3 kpsi, the stress in the y direction is equal to 9 kpsi, and then the shear stress is equal to minus 4 kpsi, right? So that's our stress matrix here. All right, so we have this is our transformation matrix. This is our stress matrix. And then we have our transformation matrix transposed, which is going to be equal to cosine theta minus sine of theta, sine of theta, and cosine of theta. All right. So if we evaluate this out, what we end up getting is cosine of theta is just radical 2 over 2. Sine of theta is minus radical 2 over 2. Minus sine of theta would just be equal to radical 2 over 2, and then the cosine of theta would be equal to radical 2 over 2. All right, this matrix is the same. The stress matrix is the same as we had before. And then we have the transpose of the transformation matrix. So we're just going to have radical 2 over 2, radical 2 over 2 on the top row, and then minus radical 2 over 2, and radical 2 over 2 on the bottom row. Okay, so we can make this a little bit easier to calculate. We can take out the radical 2's over 2's from the transformation matrices. Right, and then we'd be left with just the 1 minus 1, 1, 1 times 3 minus 4 minus 4, 9, and then we get 1, 1, minus 1, and 1 for our last transformation matrix. If you evaluate all this out, you get the radical 2 times radical 2 over 2 is going to be equal to 1/2, and then we get, if you multiply the first two matrices together, we'll end up getting 1, so we get 3 minus 3 plus 4 for the first one, for the first row, first column. For the second, first row, second column, we get minus 4 minus 9. For the second row, first column, we get 3 minus 4. And for the last column, we get minus 4 plus 9. All right, and then we have to, again, multiply that new matrix by 1, 1, minus 1, and 1. Okay, so really quickly, just adding these terms up, we would get 7 minus 13 minus 1 and 5. Okay, So we multiply this all out. You should end up getting is you get 1/2 times 7 minus 13. We would get the second column, we would get 7 minus 13. For the second row, first column, we would get minus 1 minus 5. And for the last one, we get minus 1 plus 5. Right. If you multiply, we do all that addition, we end up getting is, we would end up getting 20 minus 6 minus 6 and plus 4. We divide all those terms by 1/2. So we end up getting our final stress matrix would be equal to 10 kPSI. So all this should be kPSI. All right, so we get 10 kPSI minus 3, and 4 kPSI. Okay, so just to reiterate, 10 kPSI is our sigma x prime, 4 is our sigma y prime, and the minus 3 terms, those are both our tau x prime y prime, okay? Which is what our problem was asking us for. All right, so if you're given the initial state of stress here, and you're given the angle of the new element, or the relative direction of the new element with respect to the new coordinate system, all you need to do is plug in the values into your transformation matrices and then do some matrix multiplication to solve for it. Okay. Alternatively, what you could do is you could have used either these algebraic equations, and you could have plugged in the values for sigma x, sigma y, and tau xy, and all the trigonometric functions to determine sigma x prime, sigma y prime, and tau xy. That would be totally fine. Or you could have used this equation on the bottom where you would have only had to do a single matrix multiplication. So whatever is easiest for you to do, you're more than welcome to do that. The nice thing about using the matrices methods is that though you have to use the linear algebra, you get all the answers once you're finished. Okay. The one thing I would like to point out as well is that if you're doing your matrix multiplication, your tau xy terms should always be equal. If they're not equal, then you made an error. All right. So that concludes this problem on stress transformations in 2 dimensions using matrices. And you could, if you want, you can check the work using the algebraic equations as well. All right.